channel, sir.
Okay, for our class today, we will start with kita Al-Fatihah. Okay, so before we continue for our class, so I want you all to open your web camera as the proof of your attendance for this class. Okay, so I will count until 3. Okay, so please prepare. 1, 2, 3. Okay, thank you. Okay, so all of you can see this slide?
Yes.
Okay, for today we will continue on the basic cadastral surveying on chapter 4. Okay, so fieldwork according to the cadastral survey regulation. Okay, but before that, you need to see the cost info and the scheme of work. Okay, all of you can see the scheme of work.
Yes, sir.
Yes, sir.
Okay, so now we are on week number 9. Okay, so under the fieldwork according to the cadastral survey regulation. Okay, so for today I will touch about the cadastral calculation. Okay, so this one actually on the previous class I already discussed, but today we need to recap back what you have learned on the previous class, and then this class also, this exercise also, I give another example in the tutorial class. Okay, in order that you need to practice and then you try to understand. From that, you know how to calculate the required bearing and distance, and then how you want to calculate the angle. Then how you identify whether the three boundary mark can be as a satisfactory datum or not. Okay, next you have a method of data collection. Okay, so this one on the previous I only brief about the method. Okay, but today we will discuss further about each of the method of data collection. And then the calibration of cadastral instrument. Okay, so this is the practice that you need to carry out. Okay, to start your cadastral survey observation. okay, or you want to continue your observation on the next day, or you have in terms of the total station every 6 months, so you need to conduct the EDM baseline. Okay, so for the course info, so we now on chapter 4. Okay, we have already done about the datum. Okay, and for today, I want to discuss about the method of data collection, cadastral calculation, method of data collection, and calibration of cadastral instrument. Okay, as an intro of the class, so you need to see what is the learning outcomes, okay, from this class. Okay, at the end of the lesson, students should be able to describe the fieldwork concept according to the cadastral survey regulation. Okay, example, a method of data collection and cadastral calculation that involve in the cadastral survey observation. Then you required to identify the calibration of instrument in cadastral surveying. So they have three types. Okay, when you need to apply, example, the daily check. Okay, when you want to apply for differential field test, and then when you want to apply the EDM baseline. Okay, so that is a requirement. Requirement in order you want to prove that the data, okay, the data in the cadastral survey, okay, follow the integrity of data that required by the survey department. Okay, so as I mentioned before, okay, for the first, you will see about the topic, okay, that we already discussed on the previous class. Okay, for today, we need to recap back, but with different data. Okay, on the previous, I only show about the example. Okay, and now you will see the data. Okay, so all of you see this sample of data. All of you can see the
Yes,
data.
sir. Yes, sir.
Okay.
Yes, sir.
Okay, so from this data, okay, when you look to the sample of data, okay, so the sequence, okay, from datum, okay, datum start from the PA, okay, and then they have a few observations, 2 to 3, 2 to 4, 2 to 5, okay, and then from here, uh, example, if you have a data like this, so you required to sketch the diagram. Okay, once you sketch the diagram, and then you will identify whether this data has a direct measurement or indirect measurement. Okay, as I mentioned before, if a direct measurement means you observe, okay, you observe your the data, okay, that you set up the equipment on top of the boundary mark, okay, your total station and your tripod on top of the boundary mark, and then you do the measurement. So that is in direct measurement. But indirect measurement, okay, any one of you can explain about indirect measurement? Any one of you? Class, you have a direct and indirect measurement. Okay, maybe someone of you can explain about what is the difference between direct and indirect measurement.
Sir, direct measurement used when measurement to observe bearing and distance from one station without obstacle.
Okay. Okay, so if you have an obstacle, so means you need to apply the indirect measurement. Is it right?
Yes, sir.
Okay, so right, so that is correct. So means for this data, and for this data, if you sketch the diagram, so you will see this data represent as a indirect measurement. So the station number 2 will be established on a free station. Okay, from a free station. Okay, then they have another station. Okay, create using a pack. Okay, 2 to 1, and then from 2 to 1. Okay, from station number 2, then you will observe to the 2 to 3, 2 to 4, 2 to 5, and then continue 2 to 6. Okay, so example, if you already sketch, so you will get the diagram like this. Okay, so the diagram like this, 2 to 1, and then from station number 2, so you observe to the 3 boundary mark. Okay, so you want to check the angle of each these 3 boundary mark, and then the comparison, the bearing and distance between each boundary mark. Okay, so the line bearing and distance, okay, that I prepare in the table, okay, that represent as the data, okay, for the line traversing. Okay, so for the dash line, okay, for the solid line represent as a lot line. Okay, so what you can do after you already sketch the data, okay, what is the next step, what you will do? Okay, anyone of you can give response? What you will do after you already sketch the diagram like this? So this one actually what you have practiced in the tutorial, what you have done on the previous class also. Student?
Yes, sir.
Please respond. What is the next step that you need to do?
Find the lattice and depart, sir.
Okay, so you need to find the okay, so you want to define the bearing and distance. Okay, you want to find the bearing and distance. Okay, from that you will calculate the latitude and depart. Okay, so you want to calculate in order you want to do the comparison. Okay, so you want to do the comparison with the PO data. Okay, so what you can see in this slide, okay, the first thing you will calculate the bearing and distance. Okay. Okay, so you will calculate the bearing and distance that I already blink. Okay, the box that blink, so that represent as the data of a bearing and distance that you need to calculate. Okay, so if you look here, 3 to 5, 3 to 4, for the PO data, you can directly get from the diagram. Okay, the diagram that I provide. Okay, and then the new data, okay, the new data for the new data 3 to 4, 3 to 5, 4 to 5, so that you need to calculate. Okay, you need to calculate based on the traversing data. Okay, and then for the PO data, BKL4 to BKL5, so that you need to compute. Okay, so you can compute missing line. Okay, using the line 5 to 3, 3 to 4, then you can get the missing line for that line. Okay, next, you will calculate the interior angle. Okay, so you will calculate the interior angle of each boundary mark. Okay, so from here you can see, okay, you can see the comparison that you can do. Okay, once you prepare the data. Okay, so from you sketch in the early stage. Okay, and then you're required to calculate the bearing and distance and the interior angle. So you separate the diagram into two. Okay, you prepare as a PO data and then the new data. Okay, so you have a data on the right and the left side. So from here you can do comparison. Okay, so you can do the comparison. Okay, example like this, if I calculate the angle at station BKL3, at the BKL3, I can conclude that the comparison only about 34 seconds. 34 seconds. Okay, and then for the BKL4, the interior angle about what the difference from here, from this data class, what you can see the difference for the BKL4. Okay, 5 seconds. Okay, and then BKL5. BKL5, 39 seconds. Is it right? Is
Yes.
it right? Okay. Okay, so from here, okay, so you can see how you want to prepare, okay, your calculation, okay, and then once you prepare the calculation and then you keep on your own, okay, and then you can refer, okay, in the future. So what you can do, okay, you separate your diagram into PO and new data. Okay, and then you calculate one by one for the bearing and distance. Then next you calculate for the interior angle. Okay. Okay, then the final. Okay. So what you can conclude that the different distance and the different distance about 9 meter, 9 mm. Okay, or 0.009 meter. Okay, so then the allowable. Okay, so the allowable means the distance more than 40 meter. Okay, so as I mentioned before, if more than 40 meters, so you need to take the distance minus 40 meter divide by 20 times with the 0.006 meter. Okay, then you get the value. Okay, once for the balance that you already minus with the 40 meter. Okay, and then the 40 meter that you already minus, so will be you have already reserved the tolerance about 0.015. Okay, so when you total up, you will get 0.022 meter. Okay, for the different bearing, okay, so there is no difference. Okay, so for BKL4 to 5, okay, the different distance about 5 mm or 0.005 meter. Okay, same thing, the BKL within the BKL4 to 5. Okay, so the distance is more than 40 meter. So means you need to take the value, okay, the value of the distance minus with the 40 meter. Okay, and then you calculate for the allowable. Okay, allowable for that line. Okay, then the allowable for that line represent as a 20 mm. So means the difference is still within the allowable, okay, for the line 4 to 5. And the different bearing is about 5 seconds. Okay, so also within the allowable. Okay, so the interior angle. So the interior angle is a 5 second. So the allowable is about 10 second. So means for the BKL4 is achieved. Okay, in order we want to consider as a the boundary mark is meet as a satisfactory datum. Okay, so that is what you can practice. Okay, during the observation, during the observation, whether you can do direct measurement or indirect measurement. Okay, so once you already decide which one that you want to carry out during the fieldwork, then you need to think from the station. From the station, example, you carry out the indirect measurement. So you need to make sure the free station can be observed to the 3 boundary mark. Okay, so once you have a data, okay, so then you proceed the calculation as I mentioned before. Okay, next we will proceed on the method of data collection. Okay, so under the method of data collection, they have 5 method data collection. So this referring to the PKUP, okay, 6/2009. Okay, so the first one GNSS method. Second, traverse. Then you have a radiation, intersection, and resection. Okay, so as a in the semester 2 student, okay, in diploma level, so you will practice as a you will apply the traverse as your method of data collection, and then you will do the close traverse. Okay, so you will see more in the next slide. Okay, so for a while we go to the first method, GNSS method. Okay, so you can see the person that use the GNSS, okay, take the observation at each point. Okay, so in this requirement, okay, in this requirement, in order you want to use the GNSS method, your GNSS need to okay, so your GNSS equipment need to have a dual frequency. Okay, dual frequency. So example, frequency L1 and L2. Okay, so that is a requirement. Okay, and then your equipment can okay, can get at least 5 or 6 satellite. 5 or 6 satellite. Okay. Okay, then you will use the RTKNet station that provide by the survey department, okay, as the control station. Okay, RTKNet control station. All right. Okay, so as you know, for the GNSS equipment, so they need to have a clear sky of view. Okay, so means you need to apply this method in the open area. Okay, next, okay, the data collection, okay, using RTKNet, RTK and GPS conventional method, okay, final output in full coordinate and used in large area and clear view. Okay, so that is what I that is actually answer to your question. Okay, so okay, So each of these point, oh sorry. Okay, each of these point, the observation need to. Okay, sorry for a while. Okay, each station need to have at least 2 epoch. Okay, it will call as a 2 epoch. Okay, so 1 epoch. Okay, 1 epoch. Okay, so 1 epoch will equal as a 10. Okay, 10 reading. Okay, 10 reading. Okay, each reading will be record at least 5 seconds. Okay, so 5 seconds. Okay, all right. So each point, as a surveyor, they need to measure, okay, at least 2 epoch. Okay, so that is a requirement by the survey department. Okay, so you can open in the circular 6 2009. Okay, so in order you want to use the GNSS method, you need to ensure that each of point you will record at least 2 epoch. Okay, and then 1 epoch equal to as a 10 reading, and then each reading will be as in a 5-second interval. Okay, from the GNSS method, okay, as you know, you will get the data in the coordinate or bearing and distance. Class? Idham? Idham in the class?
Yes, sir.
Okay, if you use a GNSS method, is it you will get the data in the bearing distance or coordinate?
Coordinate, sir.
Okay, so if you use the GNSS equipment, so you will get in the coordinate. Each point you will get the coordinate. Okay, so in this method, you get the coordinate for each station. Okay, from the coordinate and coordinate to another station, then you can get the bearing and distance. Okay, there is a opposite direction when you apply the using the total station. Okay, from the total station you will get the bearing and distance. Okay, so next we move to the traverse. Okay, so traverse a series of line that consists of bearing and distance observation. Okay, and then the observation on both face. Okay, you already done, okay, using the total station, and then you already identified, okay, where is the face left, and then which one is the face right. Okay, so from that, in order you want to start your measurement, okay, so you know in your form, okay, in your form, so you will see there is a okay, sorry. Okay, from your observation, okay, so you need to take the face right, face left first, okay, and then you will continue with the face right. Okay, so that is important when you use the total station in the field observation. Okay, so you need to ensure that you set the data. Example here 2 to 1. Okay, the data that you need to set. Okay, so you need to set to 245, 07, and 44. Okay, using the face left. Okay, 2 to 1. Then you will continue on the face right, which you minus 180. Then you will insert the value 65 degree 07 and 44 second. Okay, and then this is what you will record as a two separate observation. Okay, then it can be classified as a open traverse and closed traverse. And then when you apply the traverse, okay, so you need to ensure that you must close to the nearest CRM station or boundary, all boundary mark, okay, and at every 25 station or 1 kilometer, okay, which one that you will achieve first. So that is the requirement in order you want to check, okay, your data once you already achieve to the 25 station or 1 kilometer. Okay, so example, this is a traverse method in a graphic format. Okay, so you can see the traversing is carried out, okay, surrounding the land parcel that you required to do the measurement. Okay, so in order you want to start, so you will start using any three type of datum that you already learned from the previous class. Okay, either datum using CRM, 2 NDCDB plus 1 solar observation, or 3 NDCDB that you check the interior angle. Okay, so that you will apply, okay, during you want to start the observation for the traverse method. Okay, and then you need to think, you need to plan, okay, how you want to carry out the traverse. Okay, cover for the land parcel that you need to do the measurement. Okay, so sometimes maybe you can cross your traversing network. Okay, maybe sometimes you can cross to the your land parcel. Okay, so maybe you have an obstacle, so that is you need to be creative, okay, during the field observation. Okay, other than that, in this traverse method, they have the observation, okay, observation to the existing boundary mark. Okay, so example line from station 5 to 7. Okay, so that represent as a radiation method. Okay, okay, so we want okay, first we touch about the close traverse. Okay, so that this is the main, okay, main of the method data collection that you will apply during the field observation. Okay, when complete cycle is made and consequently the work can be checked and adjusted. Okay, a closed traverse begin and end of on the same point, okay, will be represent as a polygon traverse. Okay, and then if you start with the non-point and then you ending at another non-point, okay, so that will be considered as a link traverse. Okay, so if you look here, this one, the land parcel, okay, example, this one land parcel 7460. Okay, so you as a surveyor, so you required to do the measurement, okay, for this land parcel. Okay, and then okay, during you try recce the area. Okay, so during recognize the area, okay, so you found two boundary mark. Okay, example boundary mark 1 and boundary mark number 2. Okay, so from that you as a surveyor, you think these two boundary mark will be used. Okay, and then you will plus with carry out the solar observation. Okay, So meaning you apply the datum type number. Datum type number what class? Solihin?
Sir, can you repeat it again?
Okay, so in this case, the surveyor will do the observation, okay, to cover for this land parcel 7460. Okay, so the surveyor decide to use two existing boundary mark number 1 and boundary mark number 2. Okay, and then the surveyor will carry out the solar observation. Okay, so this one will be considered as a datum type number 1, 2, or 3.
Two. Two.
Okay, datum type number 2. Okay, so example here. Okay, you have a reference station. Okay, 2 boundary mark. Okay, then you have the datum line. Okay, so you carry out the observation, then you continue traversing, okay, surrounding the lot. Okay, and then at the end you close back to the line 1 to 2. Okay, so this one represent as the close traverse. Okay, close traverse. Okay, how you want to where you want to set up the station. Okay, where you want to set up the station. So that is during the fieldwork you need to have the calculation. So at least you will know, okay, whether your station, okay, is suitable to be placed at the location that you already decide, and then that should be a stable area. Okay, and then the important things you can visible to other station. Okay, example, you want to set up a station number, you want to establish a station 4. Okay, so you need to ensure that from station number 4 you can set or you can refer to the station number 3, and then at the same time for the another staff, okay, another student, so maybe set up for station number 5. So the surveyor, okay, and another person at the station number 5 need to communicate at least this between this station is visible to each other. Okay, so that is the requirement. Okay, if you have an obstacle, okay, so you cannot proceed the observation. Okay, so that is you need to be creative. Okay, during you go to the site, okay, you handle for the field measurement. Okay, so this is the things that you need to consider. Okay, other than what the equipment that you need to bring, what the others document that you need to bring for the fieldwork, and then what the others necessary that you think you need to things during the fieldwork observation. Okay, so next you can see here you have two different we call as a boundary mark, okay, to CRM1 and CRM2. Okay, so the observation start from CRM2 to CRM1. Okay, so then continue to the station 3, 3 to 5, and 5. Okay, and at the another CRM number 3. Okay, so this one consider as a link traverse. Okay, so this link traverse you will apply during the cadastral 3. Okay, so you will apply during the cadastral 3. Okay, so before we continue to the open traverse. Okay. Okay, class. Now you can see in the jam box, or we call as a whiteboard. Can you see?
Yes.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, so during you want to apply the closed traverse method, okay, during you want to apply the closed traverse method, the things that you need to consider, how you want to record the data. So this I want to touch a little bit, okay. Another, okay, another how you about the how you want to calculate the C correction and then M correction. So that will be discussed in the chapter number 5. Okay, for the chapter number 4 for right now, okay, I only want to touch about the requirement, okay, how you want to write down in your field book. Okay, example here, the first thing that you need to write down about datum. Okay, datum, how you want to start. Okay, so this one you can refer from the compass. Okay, and then you can refer from the existing certified plan. You can refer from the pre-com plan. Okay, so that how you want to start. On the previous, you only assume. Okay, so if you recap back what you have practiced on the last semester, semester 1, okay, you will apply the assume datum. Is it right, class?
Yes, sir. Yes, sir.
Okay, then okay, so here, okay, you will start write down, okay, your from station and to station. Okay, then for the vertical angle, okay, so for the vertical angle you need to take, okay, face left first. Okay, face left. Okay, example now 2 to 1. Okay, 2 to 1 you record vertical angle face left. Then for the distance here, the distance here, it can be a horizontal distance, okay, or slope distance. Okay, horizontal distance or slope distance. Okay, in this example, okay, the first line, okay, you record the vertical angle, and then here, okay, you will record as a slope distance or horizontal distance. Class, you already practice during the fieldwork. Slope distance or horizontal distance?
Horizontal.
Horizontal.
Slope distance.
Horizontal.
Slope distance, because you record this one, the vertical angle here. Okay, so next here will be as a slope distance. Okay, and then the final distance, Okay, final distance only for the horizontal distance. Okay, so this one you need to alert. Okay, you need to alert. Okay, 2 to 1. Okay, so here you write down. Oh, sorry. Okay, sorry. Okay, so here you will record 2 to 1. Okay, you see 2 to 1. Then the value that you already write down here from CP that you refer, so you already write down here automatically. And then you minus 180 and then you write down in the phase right. Okay, in this case, 2 to 1, okay, you already record the data. Then from 2 to 1, you observe 2 to 3 here. Okay, so you turn your total station to the forward station, then you record for the phase left data. Okay, so once you record the phase left data, okay, so this one automatic you can write down from station to station. Then this one, okay, you write down as a H. Okay, in the cadastral we only focus into the horizontal about the 2D data. Okay, 2D data in terms of the position. So you're not required to take the vertical angle. Okay, unless you carry out the engineering work. Okay, then for here, you not take the vertical angle. So now here you will take as a
Horizontal
slope
distance.
distance or horizontal distance.
Horizontal distance.
Horizontal.
Okay, so for now you will record as a horizontal distance. Okay, so now finish. Okay, so finish for your observation using the face left. Okay, then once you finish for the face left, so what is the next step?
Face right.
Okay, proceed to the face right. Okay,
Yes.
proceed the face right. That okay, you need to set as a 65 degree 0 7 and 44 second. Okay, so you turn back to 1. Okay, your observation, then you set the reading, then you don't forget to record the vertical angle. Okay, so you record the vertical angle. Okay, so when you total up, okay, this one, okay, so the different limits that you can refer in the circular 6 2009. Okay, the limit 1 minute. Okay, 1 minute. Okay, the tolerance. Okay, and then for here continue record as a slope distance. Okay, using the face right, and then for the horizontal distance only, okay, one time you take using the face left. Okay, once you already finished 2 to 1 for the face right, then you turn 2 to 3. Okay, then you record for the face right data. Okay, once you record the data, or before you record the data, okay, so you need to think the limit between face left and face right should be not more than
10 millimeter.
10 minute. 10 minute.
okay, referring to the circular, okay, so the limit are 20 second. Okay, so only 20 second. Okay, so meaning you need to check whether the value here, okay, is more 20 second or not. Okay, so if not more, okay, so you can proceed. Okay, then you calculate the mean bearing here. Okay, mean bearing you put here. Okay, then next for the face right, you not or finish yet. Okay, so you don't forget to take the horizontal distance. Okay, for face right. Okay, then for the final distance, okay, so you can average from these two data. Okay, so that is how you um, Okay, so how you record the data. Okay, how you record the data. Okay, in order you want to carry out the traverse method. Okay, to control your survey area. Okay, any question that you want to ask about this, how record the data? About the correction, C correction, M correction, that one will be covered in chapter 5. For right now, any question? Okay.
No, sir.
Okay, if no question, I will move to another. Okay, next.
Person.
Okay, then now we go to the open traverse. Okay, so for the open traverse, it will begin with the known point and then ending with unknown point. Okay, the reliability of the traverse cannot be checked. Okay, useful when the survey is a long narrow strip. Okay, so this open traverse, okay, so you are not applied in the cadastral, okay, especially in UITM, okay, because we want all of the student, okay, use in the GLS160, okay, you know how to carry out, okay, using the closed traverse, okay, using the closed traverse, and then you know how to calculate the correction, okay, you check the accuracy of the traversing, okay, so from that, okay, at the outside, okay, maybe during the practical, so maybe you will involve with the open traverse, okay, not only in the cadastral, sometimes you will apply in the engineering also. Okay, so this is the example. Okay, so you will start using from the reference station. Okay, example here 3 boundary mark, and then you will continue your traversing, and then you will end at the station that you want to end of your observation. Okay. Okay, so next we go to the radiation. Okay, so in the radiation bearing and distance observation, the same thing. You will record the bearing and distance, and then you will be record the data on the both face left and face right, and then it will be recorded as a two separate observation. And the maximum distance, for the line that you can do the radiation is about 300 meter. Okay, so maybe you sometimes, okay, in the future, so you have the line that more than 300 meter. Okay, if you have a more than the 300 meter for the radiation line, so you need to ensure the line will be close to another CRM station. Okay, CRM station or the existing NDCDB. Okay, so because the radiation line it has same as the hanging line. Okay, so if the already achieve maximum distance, okay, that allowed, okay, in the circular, so you need to have a proof that you close to the CRM or existing NDCDB. Okay, so the example of the radiation method. Okay, so the first one from station 1 to until 6, that represent as a traverse method. Okay, we call as a link traverse. You start with non-point and then you close with also non-point at another place. And then from each station, okay, example from station number 2, you observe to the 2 to A, 2 to B, okay, until 2 to D, that represent as a radiation method. Okay, Same to the station 3, 4. Okay, so this one another example. Okay, refer from station BKL2 to BKL1. Okay, continue until BKL5. Next, from station number 4, okay, observe to each of the corner for land parcel PT3001. Okay, so this we consider as a radiation line. Okay, so you see this one, okay, why I mentioned as a hanging line. Okay, so it's only have a line, okay, that connecting to another boundary mark. Okay. Okay, next method, intersection method. Okay, in this method, the same thing, bearing and distance observation. Observation only using a single phase. Observation are made from two different stations. Okay, so this another new method. Okay, based on the circular 6/2009. Okay, intersection method. Okay, to A, to B. Okay, and then you look from station 3, okay, also observe to the point A, point B, point C that already measured by from the station number 2. Okay, so next resection method. Okay, so the same thing also with the intersection. Okay, bearing and distance observation, observation on single phase. Observation are made from one unknown station to 3 different known station. Okay, traverse method. Okay, D to 1, B to 1, okay, D to 1, okay, B to 1, and then A to 1. Okay, so this another a new method. Okay, we call as a resection method. Okay, but for all of you, okay, you need to focus on the close traverse method. Okay, in terms of how you want to cover your area. Okay, the area that you need to measure. Okay, how you want to start. Okay, how you want to plan, establish the station, and then once you already cover your area, okay, so you need to ensure during your field observation of traversing, okay, follow the clockwise. Okay, so your traversing need to follow the clockwise. Okay, and then okay, when you already cover your area, okay, the area that you required to measure, okay, at the end you will produce a certified plan. Okay, you will produce a certified plan based on the measurement that you have been done, okay, to the survey area that you required to do the measurement. Okay, I mean about the lot, okay, that you need to show in the certified plan, not your traversing line in the certified plan. Okay, so that you need to understand. Okay, from your traverse method, you cover the area. Okay, once you cover the area, another things you required to planted a new boundary mark. Okay, for the corner that already missing the boundary mark, or the place that you required to planted a new boundary mark. Okay, so the requirement, you need to ensure that the boundary mark need to planted at least on top of the boundary mark, about 8 centimeter. Okay, 8 centimeter above the ground level. Okay, so from the ground level 8 centimeter, so you can see the boundary mark. So that is a requirement, okay, in the circular. Okay, so before I continue with the integrity of cadastral data, okay, so I will take another attendance for our class today. Okay, so please open your web camera. So this another I want to check. Okay, so at least when I ask you question, okay, so you can respond. Okay, so once you respond or you ask the question, so at least I know that you have the interaction, okay, with me. Okay, so I will count until 3. 1, 2, 3. Okay, smile. Okay, so any question right now? Maybe you want to ask the question before I continue with the calibration.
No, sir.
Okay, how many of method for data collection? 4,
5.
okay, 5.
5.
So which one?
5, sir.
5, sir.
Okay, 5 method data
I think
collection. Okay, so which one that you will apply during your field observation?
Traverse.
Okay,
Traverse.
so traverse.
Traverse.
Okay, so traverse, you will focus on the close traverse.
Yes, sir.
Okay, so in the close traverse, what the criteria that you need to think before you want to start the survey?
Start traverses with a proper datum.
Reference.
Okay, so you need to think about the datum. Okay, so you have learned on the first subtopic in the chapter 4. Okay, you have 3 type of datum. Okay, so which one will be used, okay, in order you want to start your field observation. Okay, so that is important about the datum. Then about the planning of you want to establish the station. Okay, so which how you select the place in order you want to make sure your station can be observed from the previous previous station and the forward station. Okay, any other question before I continue?
No, sir.
Okay,
No,
so
sir.
if no question, I will continue with the calibration. Okay, so in the cadastral, so you need to think about the integrity. Okay, because the all the documentation, okay, will be kept by the survey department. Okay, so anything regarding the document that you want to do for the cadastral data, okay, so you need to refer to the survey department. Okay. All measurement must assume as valid in observation and cannot dispute if follow. Okay. Okay, all instruments must calibrate and follow circular that mentioned by the survey department. Okay, or we call as a JUPAM. All observation must follow guideline and procedure as stated by the survey department. Okay, so each of these statement, okay, each of these statement, so they have a circular. Okay, example, I discussed about the calibration. Okay, so calibration. So I need to mention about the circular that talk about the calibration. Okay, and then about the guideline and procedure. Okay, what is the current circular that you need to refer? On the previous, you have circular 2002. Okay, so but now you have a 6/2009. Okay, in that circular, okay, so you can see the requirement that you will apply, you will practice during the field observation in the cadastral survey. Okay, so for you all, you can refer on your textbook. Okay, so that textbook already okay, have the extraction of the information from the circular. Okay, and then combination with other data and from the other sources. Okay, and then that will be as a textbook that you can refer for this semester, next semester until you graduate. Okay, so at least you already practice on this semester. Okay, you will apply on another semester until you practical. Okay, before you graduate. Okay, so for the calibration, okay, so calibration, you have a circular that you can refer. Okay, example, the first one, 6/1986. Okay, this regulation for handling the electronic distance measurement, okay, EDM, for the cadastral survey. In addition, the technical and procedure related to the electronic distance measurement EDM for cadastral survey that necessary are stated. Okay, about the technical, about the procedure, okay, regarding to the total station EDM, okay, already stated in this circular. Okay, next, circular 3 of 1986. This circular allowed the use of an electronic distance measurement for cadastral survey. Other than that, there are also stated about the tests that required for EDM calibration. Okay, so this one talk about the tests that required for the EDM calibration. Okay, another circular here. Okay, 6/2009. Okay, all the equipment should be calibrated at least every 6 months for the total station equipment, and at least every year for the GNSS equipment. Okay, so this is okay, the new, okay, equipment that you will apply in the cadastral survey. Okay, because as you learned before in chapter 1, the e-cadastral objective, one of that is about the talk about the, in term of the GNSS. Okay, so now you see, in order to match the delivery faster, okay, so the GNSS method already have in the data collection. So in order to use the GNSS equipment, so they also have a calibration. Okay, so the calibration for the GNSS equipment, you can refer to the another circular 1/2008. Okay, so that is another circular for the GNSS equipment. Okay, so example, when you apply in the for the method data collection, so you need to achieve for the result in term of the coordinate north south or east west, so at least 2 centimeter each of the north south, and then east west the different, at least 2 centimeter. Okay, So next, the field check routine calibration is essential to ensure that the instrument is in acceptable working condition. Okay, so example here, by using the total station, okay, so you required to conduct these three calibration. Example, the first one, daily check, second, differential field test, and the third one, EDM baseline. Okay, so as you have done during your practical, okay, so you have done apply the differential field test. Okay, so you learn, okay, you learn how to set up to conduct the differential field test. So what the things that you need to record, so at least you already know, but you not have the opportunity to conduct for the daily check and EDM baseline. Okay, so it doesn't matter. So that one maybe you will cover on the other semester. For a while you just learn as a ODL session. Okay, so the first thing you need to know about the when you need to apply the daily check. Okay, so daily check or daily test should be carried out at the start of everyday job. Okay, example, you have first alienation, okay, for today. Okay, you start conduct the observation, then tomorrow you want to continue. Okay, in order you want to continue on tomorrow, the first thing that you need to do, you need to carry out the daily check. Okay, it can be done by remeasuring the distance of the last survey line on the previous day. Okay, so it means you need to remeasuring on the previous line. Okay, so that actually what you will do. Okay, you will set on the previous station, okay, on the previous line, okay, before you continue to the forward line. Okay, if the error is greater than 10 mm, the differential field test need to be carried out to ascertain if the EDM is in acceptable working condition. Okay, so that is the things, okay, that you need to alert, okay, about the tolerance about 10 mm. Okay, example, okay, the line that you finish, okay, on today, example 8 to 9. Okay, the observation have been done 8 to 9. Okay, so T is the last line, okay, for today. And then tomorrow you will continue. Okay, tomorrow you will continue. So means your total station for tomorrow, you will set up as station number 9. Okay, then you will set up the prism at station 8. Then you will set the reference line. Okay, before you continue 9 to 1. Okay, so this is what you need to apply the daily check. Okay, so from 9 to 8. Okay, so you have a few data that you need to record. Example, vertical angle, slope distance, and then last you will record the horizontal distance. Okay, horizontal distance from station 9 to 8, you will compare with the horizontal distance from 8 to 9. Okay, so the difference should be not more than 10 mm. Okay, so this one, the things that when you apply during the field work, okay, then you will know, okay, whether you can know the station that you already created on the previous day. Okay, this is a mistake by the students. Sometimes they will not okay, not have a mark for the packs, okay, that already create as the station. Okay, when the student go in order to continue the observation on tomorrow. Okay, so the student cannot find where is the place of the pack. Okay, and then maybe, okay, the student will set up on any pack that he or she found. okay, and then uh, the student will continue the observation. Okay, if the student continue the observation, okay, without without apply the daily check, okay, so this is the things what happened when the end of the traverse network have been closed, okay, the accuracy is not achieved. Okay, so this is a mistake about the what happened. Okay, you not achieve the first class survey 1 ratio to the 8,000. Okay, is it you all clear about this daily check?
Yes, sir.
Okay, so this is how you record the data. Okay, example 8 to 9 is the last line. Okay, 61.064. Okay, then on another day, the first thing you will do the daily check here, 9 to 8, then you will record the vertical angle. Okay, slope distance. Okay, and then horizontal distance. So this horizontal distance you check with the previous line. Okay, then you will continue, okay, your observation for the forward station. Okay, so this is the same thing. When you start your datum, you will record vertical angle, slope distance, and then when you want to continue on the tomorrow, on the others day, okay, so you will apply the daily check, and the same thing, you will record the vertical angle, slope distance, and at the last horizontal distance. Okay, so next about the differential field test. Okay, differential field test. So this one what you already practice during the field practical before. The differential field test should be carried out at the start of every new survey job. Okay, it's important to ascertain if the EDM is in the acceptable working condition. Okay, for work which started by using 2 CRM, which it is visible site, differential field test should be made on this line. Okay, example nowadays, the surveyor will start the observation using datum from CRM. So what the surveyor can do, okay, the first thing they can do on top of the 2 CRM, okay, they carry out the differential field test. Okay, if exists any difference of a distance between direct observation, okay, direct observation from the total station compared to the two result of a 2 CRM station, okay, the compute or new observed distance of the 2 CRM station should be used as a final distance. Okay, so when you do on top of the CRM, okay, and then you check the distance. You check the distance; they have a difference. So you take the value distance from the difference between 2 CRM station as your final distance. The different limit is not exceeding 0.020 meter. Okay, so this one as a new stated in the circular. For different exceeding limit 0.02 meter, okay, action following must be taken if DFT not exceed 0.010 meter, determination CRM must be done again. Okay, example, if DFT, okay, okay, the different limit, okay, about 0.02 meter, okay, then what the surveyor can do, okay, try to determination by a new CRM, okay, try to re-observe again, okay, in order to get a new coordinate data for the each CRM. Okay, from the coordinate and coordinate, okay, can calculate the distance. Then DFT exceed the limit, so means the total station should make a calibration. Okay. Okay, so this is example how the surveyor or you as a student, you need to record the data for the differential field test. So this one should be early, okay, or on top of the datum. Okay, so you will start with the differential field test A to B. Example, your A to B 60.234 meter. Okay, so you will record as a face left and face right. Okay, then you average. Okay, next you create online, okay, another station online to the line A to B. Okay, so then you do the measurement from C to A. Okay, you do the measurement C to A, then you get a distance for the face left and face right, then you average. Okay, then you record here as the final distance. Okay, last you observe C to B. Okay, C to B, face left, face right, then you write in the final distance. Okay, last you write down again C to A, then A to B, you total up. Okay, so you can see whether they have a difference or not. Okay, so this one how you want to record in the field book. Okay, so this how you want to conduct at the field survey. Okay, establish two wood pack. Okay, example point A and point B at least 50 meter. Okay, at a flat surface area. Okay, at the end of the point, okay, example at the point A you set up the EDM or the total station, and then at the station B you set up the reflector. Okay, so next you measure distance between A to B. Okay, okay, once you already measure distance A to B, so next what you will do. Okay, so what you will do, class, based on your practice in the fieldwork. Okay, any one of you, please respond. What you will do once you already observe A to B.
A and B.
Okay, so you need to establish a new station. Okay, you need to make sure that that station, okay, same as a online with the line A to B. Okay, okay, so example here. Okay, you already set up or establish point C. Okay, so once you already established the point C, then you move your total station, okay, to the center at the point C. Then from point C you observe C to A. Okay, you measure C to A, and then you measure C to B. Okay, then you total up the distance C to A and C to B. Okay, you do comparison with the distance A to B. Okay, so you need to ensure that the error is not greater than the 10 mm. Okay, so if not, if more than 10 and 10 mm, so the EDM should be calibrated. Okay, so next, continue with the EDM baseline. Okay, so this is another calibration that you need to do. Okay, example, at least 6 months. Okay, every 6 months, your total station need to go to the you need to do the calibration. A series of measurements on a baseline can also be used to check the performance and reliability of the instrument and to assess its precision against the manufacturer claim and specified minimum distance. Okay, so this one, the equipment already have the specification, okay, by the vendor. Okay, and then So from time to time, when you use the EDM or total station, so you need to check. Okay, if you have a problem with the EDM or total station, okay, and the reading is not constant between phase left and phase right, so means that you need to do the calibration. Okay, example here, a set of total station must do calibration at EDM test sites as following. Example, every 6 months, okay, or after service, okay. If any change to part of total station, any broken part due to fallen, okay, and then the distance reading, example, phase left and phase right is not consistent, okay. So all these things when the reason why you need to do the calibration. Okay, example, the pillar, okay, at the pillar test site, okay, you will look like this, okay, and then on top of it, it will lock, okay. So the key you need to borrow at the district's survey department, okay. So example, if you as a student, okay, maybe one day you required to do EDM calibration, okay, EDM baseline calibration. So you need to prepare a letter, okay, in order you want to borrow the key from the district survey department, okay, in order you want to use the EDM test site, okay, to carry out the calibration. Okay, this pillar 1, so they have a 10 pillar, okay, pillar 1 to pillar 10, okay, the distance about 300 meter. Okay, built with a straight line containing 10 pillar, okay, every pillar have its own ID or number, okay, example number 1 to 10. Then the maximum distance of a first and last pillar are about 300 meter, and the average constant error does not exceed 10 mm. Okay, so at the last when you check the data, okay, and then you compare with the existing data that provided by the survey department, okay, so you will check, okay, whether the result is more than 10 mm or within the 10 mm. Okay, this is an example how the measurement you will conduct during at the EDM test site. Okay, you have a 10 pillar set up EDM at pillar number 1, prism at pillar number 2. Then you measure the distance for pillar 1 to 2. Okay, so on top of it, you set up the EDM for pillar number 1. Pillar number 2, you set up the prism. Okay, example, you bring 3 prism. Okay, so you can put like this at pillar number 2 and pillar number 3, and maybe one of you, okay, you will go at the last pillar, okay, pillar number 10. Okay, and then once your friend already measure from 1 to 2, okay, this EDM, this prism can be moved to pillar number 4. Okay, while your friend will be measured from pillar number 1 to pillar number 3. Okay, so this measurement will be conducted until the reading from pillar 1 to pillar 10. Okay. Okay, next what you will do. Okay, so next you will move the total station, okay, to the pillar number 2. Okay, then you will measure from 2 to 3 until 2 to 10. Okay, 2 to 3 until 2 to 10. Okay, so now until 2 to 10, you already have 17 data. Okay, 17 data. Okay, and then you want to complete as a 20 data of your observation. Okay, then you can move your total station to pillar number 3. Then example, your prism at station 10, okay, at pillar 10. Then you can measure from 3 to 10. Okay, then your friend can move the prism to 9 to 8. Okay, 3 to 9, 3 to 8 in order to complete the reading as a 20 data. Okay, from 20 data, okay, you will compare with the existing distant data that maintained by the survey department. This EDM test site, okay, will be maintained by the survey department. Okay, so they have the existing, the current data between pillar to another pillar. Okay, so this is example how you record the data. Okay, how you want to prepare your form. Okay, you have a distance, horizontal distance, and then you have a existing distance, okay, from the survey department. Then you will do the comparison. Okay, so at the last you get 0.06. 0.06 here you divide by number of data. So here you have 20 data, so you divide by 20, so you will get the 0.003 meter, okay, or equivalent to the 3 mm. So this 3 mm is less than 10 mm. So that represent that this instrument is acceptable to be used. Okay. Okay, so this is an example of the form. Okay, if you have a form by from the survey department, so you will look the form like this. Okay, so the required information when you conduct the test. Okay, what the model of your total station, where is the place, what about the temperature, the serial number. So this is important. Okay, this is important. So the officer need to know, okay, what the serial number, what the type, okay, and then what the measurement have been done, what about the result from the measurement. Okay, and then you as a student, you need to identify where is the location. Okay, where is the location you want to conduct for the test site. Okay, EDM calibration. Okay, because this is important. Example, you go to the practical, okay, or you work at the outside. Okay, and then the first test to you, okay, you need to conduct the EDM baseline calibration. Okay, example, you in Selangor. Okay, you in Selangor. So where is the place in order you want to go to the EDM test site? Okay, so if you look here, EDM test site in Selangor, the location at section 6 Shah Alam. Okay, so section 6 Shah Alam. Okay, so that you can use the test site in order to test to carry out the EDM baseline calibration. Okay, so the others stated as a GNSS. So GNSS is for the GNSS equipment. Okay, to calibrate the GNSS equipment, so you need to see where is the place for GNSS test site. Okay, example in Perlis. Okay, if you at UiTM Perlis, so the GNSS test site, where is the location of GNSS test site in Perlis?
ITM Marau.
Okay, UiTM Arau. Okay, so maybe today you realize, okay, in UiTM they have a GNSS test site. Okay, so this test site will be maintained by the survey department. Okay, they enter to the UiTM and then they will check, okay, each of these pillar, okay, in order to conduct for the GNSS test. Okay, for EDM, okay, so you need to go to the Sungai Batu Pahat Perlis. Okay, so this is a place. Okay, other than you visit the snake area. Okay, museum of snake. Okay, then you can conduct the EDM baseline calibration here. Okay. Okay. As a summary from our class today, okay, so there are 5 methods of data collection. Okay, so from the 5 method of data collection, so you need to focus to the traverse. Okay, so under the traverse, you need to going down to the closed traverse. Okay, from the closed traverse, you need to think about the datum to start the survey, and then how you want to carry out the traverse. Okay, you need to ensure make sure that the traverse carry out in a clockwise orientation. Okay. Okay. Other than how you want to apply the correction, the in term of how you want to check the accuracy of the traversing, so that I will touch in the chapter 5. Okay, chapter 5 about the recording data. Okay, and then how you want to do the adjustment of the data. Okay, next, the field check routine calibration is essential to ensure that the instrument is in acceptable working condition. For instance, daily check, differential field test, and EDM baseline. So these 3 type of calibration is important in order to make sure the integrity of data for the cadastral survey. Okay, and then this is the key. The key when you conduct the traversing. Okay, that is important when you continue to another. You continue the observation on the another day. Okay, so the first thing you do the daily check. Okay, once you do the daily check, so you will know whether you continue your observation, okay, using your packs or you use another packs. Okay, so this is what happened in your ITM. When you continue, you use your friend pack. Okay, and then at the end, when you close your traversing, okay, do not achieve the accuracy. Okay, 1 ratio to the 8,000. Okay, so that is a mistake by the student. Okay, so I always mention, okay, to the student, okay, when you want to continue from one station to another station, okay, the first practice you need to check. Okay, because this is semester 2 is the your new environment in order to carry out the cadastral survey, engineering survey. Okay, so this is the things that you need to check. Okay, from time to time. Okay, when you already in you want to graduate, so maybe you, during that time you already familiar. You already know. Okay, where is your mistake? Okay, so for this level, okay, so you need to check from time to time, okay, in order to get the first class accuracy. Okay, for the next topic, okay, so I will touch about the offset, okay, offset in the cadastral, and then we will move to the chapter 5. Okay, so now is the session for question and answer. Okay, anything you can refer to the circular 5 2009 and 6 2009. Other than that, you have your own textbook. Okay, so you can refer to the your textbook. Okay, if you have anything that you not clear. Okay, other than maybe you can ask me about any question, okay, that you want to ask regarding the cadastral survey. Okay.
I have
Okay,
a
you okay.
I have a question. Why do we have 5 method of collecting data? Is it because um we have like so many thing? Sorry. I mean, it is because we have a different land or a a different circumstance. So we should have that 5 method to use each one of it when we apply on certain situation.
Okay, so as you know, in this current situation, okay, in order to achieve the e-cadastral, okay, one of that they have a one of the objective is use the GNSS. Okay, so when you want to use a GNSS, so nowadays many license and surveyor, and then the surveyor also have used the GNSS equipment, okay, because the price is already lowest compared to the previous price. Okay, so now they can use the GNSS equipment. Okay, so from GNSS equipment, okay, with the control station that provide by the survey department, TKNet, so they can do a connection with the TKNet, okay, in order to get the real-time data, okay, without need to have post-processing data. Okay, so if as I mentioned before, real-time data you can get the directly coordinate that you can use. Okay, if a post-processing need you need to go back to the office, okay, you need to do the processing, okay, you need to open your laptop, you do a post-processing, then you can get the coordinate that you can use, okay, already the coordinate that already have the correction that already apply. Okay, so that is why nowadays they have a GNSS method, okay, to the cadastral survey. Other than that, now, okay, for the chapter 5, okay, you will learn about the adjustment of the body adjustment, okay, but another semester 3 you will use the least square adjustment, okay, using the standard, okay, how you adjust using the new adjustment that apply in the cadastral survey. Okay, so from that you can compare on the previous we use a body, but now we already apply the least square adjustment, so you can see the comparison. Previous we focus collect the data from the bearing and distance, okay, but now we from the coordinate, okay, so we can process transfer to the bearing and distance. Okay, other than that, you have a traverse and radiation. Okay, so that actually the combination that what you apply during the fieldwork. Okay, when you want to pick up the boundary mark, okay, so that represent as a hanging line, so that also as a radiation line. Okay, you want to planted a new boundary mark, so you will do the radiation method. Okay, okay, other than that, intersection and resection, okay, so that is depend on the situation. Okay, example at the flat area, okay, so you have a open space, okay, so that is suitable in order you want to apply the intersection and resection method. Okay, so that is a new method in the current environment. Okay, so any other question? Okay, if you don't have any question, okay, so I hope, okay, so you know from this class today, okay, you already learned about the first the calculation, okay, how you want to prepare the calculation in a proper way, and then from that you have from the diagram, automatic you can describe the result, okay, so that is cadastral calculation. Then about the method of data collection. Next, about the calibration. Why you need to carry out the calibration. Okay. Okay, so I think that's all for today. we end our class with Surah Al-As and Tasbih Kifarah.